So I haven't started to grade them yet. As soon as they all come in, I'll get them graded. Probably won't have them back to you until sometime before Wednesday's class next week. Now make sure if you haven't yet, you can still go back to the first test and redo those problems you got wrong and send me an email. There are a couple of you I noticed that still haven't done that. The target you are looking for in this class is you have to average 80%. So if you didn't have at least an 80% on that first test, it's vital that you go back and redo those problems you got wrong. And even if you did better, I mean, there's some students that get a 98% and they still do corrections to get that 1 point back. You never know when that point's going to make a difference at the end of the semester. So please feel free to do that. If you don't know how to redo those questions, feel free to talk to somebody, work with somebody at your school, work with one of the math teachers there. Send me an email. I would be happy to try to step you through it through email if we need to. But make sure you get those questions done and sent back to me. And all you really have to do is just send me an email saying, question number 1 or question number 18, whatever, and show me the steps to get to the answer and what the correct answer is. So if you're not sure what to do on any of those, or if yours is one of the tests where the inking from grading didn't show up, let me know. Just send me an email and I can send you back which numbers you had wrong or whatever. But I want to make sure you guys get as many points as you can out of that. For those of you in Chequamegon just coming in, I said I haven't got all the tests yet for test 2, so I have not graded those yet. But for test 1, make sure you go back, and if you have not yet, make sure you go back and redo the ones you got wrong so you can get back those points. So I should have those tests back for you, like I said, by Wednesday next week. We're going to be starting Unit 3 today. And Unit 3 is really the heart of the course. It's dealing with dosage calculations. There's a lot of background information we have to lay down as we're getting through that. So today and then most of next week, we're going to be looking at doing that background information that we need to get up to where we can really do the meat and potatoes of the dosage calculations. Then, of course, after next week, I have my spring break goes from March 20th through the 24th. So there won't be class that week, so you guys will get a week off then. And then after that week, we've got some conflicting schedules that we'll deal with. So we'll discuss that next week sometime before we go on break. But I know there's at least one of you guys that has a full week spring break in there that we're going to have to contend with. But we'll deal with that later. So let's get started here right now with the beginnings of this dosage calculation. And we laid the background for this first concept when we did ratio and proportion in the last unit. And what we're talking about here is the dilution. And in a dilution, what we are doing is we are taking some sort of a medication or a concentrated fluid, and we're using a neutral fluid, one with no medicinal value, and we are using that to dilute it down, to make it less concentrated. So there are 2 terms that we're going to be using here, generic terms. I'm using the term serum. Serum is going to imply either a medication, some sort of a bodily fluid, could be blood or urine, or just a concentrated solution, the higher concentration of the solution. Then the other term we're going to be using is the abbreviation NS. NS could stand for, one of its things it stands for is normal saline or neutral solution. Basically what it is it's sterile water. It's sterile water that has been pH balanced so that it is at the same pH as your blood. If I remember right, blood pH is between 7.25 and 7.45 on the pH scale. So the water has been normalized to the pH level, and then other things, the mineral levels have been very carefully controlled in this. Any harmful things have been taken out and it has been sterilized. So the term NS is basically going to be some sort of a non-medicinal dilutant. It's something we're going to add to it that reduces the concentration of our main substance. So the serum up here, if you think back to the terms of our mixture problems at the end of Unit 1, or the beginning of Unit 2, the serum up here is going to be our active ingredient. And this is going to be our solvent, or our dilutant. So anyway, let's take a look then at what a dilution really is. A dilution is just a ratio. And it is a ratio of serum or concentrate to the total volume of solution. So if we have a 1 in 4 dilution, what that is saying is we have 1 part serum, whether that's a medication, blood, urine, whatever, we have 1 part serum to every 4 parts of total solution. So to deal with this ratio, we might have, we might be asked how much hydrogen peroxide is in a 1 in 6 dilution with total volume of 300 milliliters. So that 1 in 6 dilution serves as our ratio. And remember, in a dilution, that first number, the 1, is the parts serum. And the bottom number is the parts of total solution. So looking up here in our problem, the 300 milliliters is the total volume. So 300 milliliters is going to go with the 6. And we are looking for how much of the peroxide. So that the peroxide, hydrogen peroxide here, is our serum. So we want to know how much that is. So that is what we're looking for up here. So we're going to cross multiply and divide. 1 times 300 divided by 6 is going to give us 50 milliliters. So it would take 50 milliliters of hydrogen peroxide in that solution. We might be asked, how much of a 2 in 9 dilution of blood in normal saline, or in our sterile water, can be made with 80 microliters of blood. Now I used 80, I used the micro symbol there. You might also see that 80 MCL for microliters. So anyway, let's look at our dilution again. The dilution here is 2 over 9. 2, of course, represents the part serum, so I'm just going to write serum there to label that. And 9 is total solution. So the 80 microliters in this case represents the blood, which is our serum here. So 80 microliters goes on top. Now the only reason I'm putting the units in here at all is because we need it to know that that's the same units that's going to be on bottom. So now we can cross multiply. 9 times 80 divided by 2 should be 360 microliters. So it would 80 microliters of blood in a 2 and 9 dilution can create 360 microliters of that total solution. We might also ask what dilution is created by dissolving 120 milliliters of alcohol into 600 milliliters of total solution. Now here we're going to have to work backwards. We don't know the ratio of our dilution here. You know, we know that what's going to go on top here is going to be our serum. In this case, that would be the alcohol. That's our active ingredient here. And on bottom is going to be the total solution. But we don't have either one of those numbers in the dilution ratio at this moment. But we do have volumes. 120 milliliters of alcohol, that's our serum. So 120 milliliters goes on top. 600 milliliters of total solution, that'll go on bottom. Now once more, the only reason we included units here is so we make sure they're the same and make sure they cancel out. And now to get the dilution, it's just a matter of reducing this ratio. Both 120 and 60 can be divided by what number? Anybody? What's one number that can divide both of them? I heard somebody say 12. So we divide 12 in there. 120 divided by 12 is 10. 600 divided by 12 is 50. Now they can both be divided by the end in 0, so they can be divided by 5 or 10, either one. So 10 divided by 10 will give us 1. 50 divided by 10 will give us 5. You could have done 5 and had 2 and 10 and reduce it again. So we get a 1 in 5 dilution of alcohol in solution there. Well, those have all been pretty straightforward because I've talked about the active ingredient and the total volume. But what if, now we had said at one point when we talked about our ratios and proportions that most of these ratios actually have 3 ratios in them. So let's take a look at a 1 in 6 dilution for a second. That ratio of 1 in 6, as we said, is the ratio of serum to total solution. There are 2 other ratios that are hidden in here. One of the more common one is the serum to water. How would we find the ratio of serum to water? Well, we still have 1 part serum. How many parts water would we have? There's 6 total parts, and 1 of those parts is serum. How many parts are left over? 6 minus 1 makes 5. So the ratio of serum to saline, or serum to water, is 1 to 5. The other ratio we have is the ratio of saline to total solution. And once we have this second ratio, of course, this one's pretty simple. Our total solution is still 6. The amount of water, if 1 part is serum, 6 minus 1, just like before, 5 parts is saline. So all 3 of these ratios are implied in the term 1 in 6 dilution. So when we see a 1 in 6 dilution, we need to look at the problem and figure out which one of these ratios we really need to solve that problem. For example, we might have how much saline is needed to mix with 80 milliliters of serum to create a 2 in 7 dilution. So once again, we've got our dilution here. Our dilution is 2 in 7. But remember, the 2 is the serum, and the 7 is the total solution. What we have up here, we have 80 milliliters of serum, so that part's okay, but we're not looking for... Okay, so we have that ratio of serum to total solution. We're given the amount of serum, but we're not looking for the amount of the total solution. So what we need is the ratio of serum to saline, because we're looking for the amount of saline. So that ratio is going to be, there's still 2 parts serum. How many parts of saline would there be in that? If there's 7 total parts, 2 parts are serum, there'd be 5 parts saline. So we've got the 80 milliliters of serum. We are going to cross multiply and divide. 5 times 80 is 400. Divided by 2 is 200. We would mix 200 milliliters of saline with that 800 milliliters of our serum. Any questions? Okay, sorry about all the noise on the network. I'm not totally sure where it's all coming from. Hopefully it'll die down in a second. Okay, so here we were asked, we needed to find that ratio of serum to saline in order to figure out what we needed here. And we could have a very similar problem where we might be asked how much serum is needed to mix with 360 milliliters of saline to create a 1 in 9 dilution. So once again, we have our dilution here. And I usually do write it out like this so that I map it out and label it. The 1, of course, is our serum. The 9 is our total solution. What we have here, though, we're given the amount of saline, and neither one of those represents the saline. So we need a ratio with saline in it. We need to figure out what is the number we're looking for but we're looking for how much serum. So we need a ratio of serum to saline, just like the last problem. What's that ratio going to be? Well, we still have 1 part serum. If we had 9 total parts, and one of those parts was serum, how many parts of saline would we have? 8. Good. 9 minus 1 makes 8. So then, we have the 360 milliliters of saline. That goes with the saline on bottom, 360. And we can cross multiply and divide. 1 times 360 is 360. Divided by 8 is 45. This is milliliters, so this has to be milliliters. So we need 45 milliliters of serum to complete that dilution. Okay, so then we might be on a little bit different note. We might be asked, how much saline is needed to create 800 milliliters of a 1 in 8 dilution. So here we have a dilution again. It's 1 in 8. Again, the 1 is serum. The 8 is total volume. We have the 800 milliliters of total solution. That's okay. But we're not looking for the serum. We are looking for how much saline. So we need a ratio that relates total solution and saline, or saline to total solution. So our saline to total we still have 8 parts total. If out of those 8 total parts, if 1 part is serum, how many parts are going to be saline? Eight minus 1 is 7, so 7 parts saline. So we've got that ratio of saline to total of 7 to 8. And now we can put in the 800 milliliters is the total. 800 milliliters of that dilution is implying that's 800 milliliters total volume. And we cross multiply and divide. 7 times 800 divided by 8. That would require 700 milliliters of saline. Similar to that, we could ask, how much of a 3 in 10 dilution can be created using 420 milliliters of saline. So once again, I'm going to write out the dilution. 3 in 10, and again, as always, the 10 is the serum. The 3, sorry, is the serum. The top is the serum. The 10 is our total solution. Here, though, we have the amount of saline is 420. Neither one of those is the saline, so we need a ratio with saline in it. And we're asked how much of that 3 in 10 dilution. So that's the total solution that we're looking at. So once again here we are looking at a ratio of saline to our total solution. So we still have 10 parts of total solution. If 3 of those 10 parts are serum, how many parts are the saline? Somebody be brave. There we go. 7. Thank you. 10 minus 3 would leave 7 parts left of saline. So over here, where does the 420 go? On top or bottom? 420 is at the saline, so it goes with the saline on the top. So 10 times 420 divided by 7 is 600. Of course, the units better be milliliters. So that is 600 milliliters of total solution. So we might be asked something a little more complex. We might be asked, how much lidocaine and how much saline would be used to create 540 milliliters of a 2-in-9 dilution. We're assuming that this is a dilution of lidocaine in water. So here our dilution is 2-in-9. The 2 represents the serum. In this case, that would be the lidocaine. The 9 is going to be the total solution still. In this problem, we are given the 540 milliliters of the dilution. So that would be the total solution. Are we looking for the amount of lidocaine or the amount of serum? Well, yeah, that's actually one of the things we're looking for is the amount of lidocaine. So 2 times 540 divided by 9 is going to be 120 milliliters. So we'd use 120 milliliters of lidocaine. Well, that's only half of our answer. To find the other half, now I realize we could just do 540 milliliters minus the 120 milliliters of lidocaine. And what's left over, 420 milliliters, should be our saline. But let's go through and figure this out with the ratios just so we've got a double check. The ratio here of saline to total will be, well, the total is still 9. If 2 of those 9 parts are lidocaine, the other 7, 9 minus 2, is going to be saline. So we still got 540 milliliters total. 7 times 540 divided by 9 is 420 milliliters of saline. So the answer to the question would be 120 milliliters of lidocaine and 420 milliliters of saline. But why are these dilutions so important? Well, we'll see more next week on using these dilutions to change the concentration of a solution, volume changes and stuff like that. But for right now, we're going to look at a very important application. Many of the meters that are used for like measuring blood glucose or different like nitrogen in urine and stuff like that. Many of those meters have a range where they're accurate, and then outside of that range they are not accurate or they don't function at all. For example, most blood glucose meters usually only function well up to a reading of 800 milligrams per deciliter. Now, when you're doing blood glucose, anything over 100 is considered higher than normal. You get over 200, you're looking at some serious issues. So 800 milligrams per deciliter is a very high blood sugar reading, but it's not impossible. So let's say that we have a patient blood sample exceeds the limits of the meter. So what we're going to do is we're going to take that sample and we are going to dilute it. We are going to dilute 30 milliliters of blood in a 1-in-4 dilution so that we can test it. And we're going to test that diluted sample. The diluted sample gives a result of 214 milligrams per deciliter. So I want to find two things here. One, how much sterile water was used to dilute it in the dilution? And two, what is the true reading then? What is the true blood level for this patient? So the first thing, we had a 1-in-4 dilution. So to properly perform that dilution, we first need to know how much saline is needed. A 1-in-4 dilution, remember the 1 is the serum, in this case the blood. The 4 is the total. So what we really need here is the ratio of blood to water, or saline. There would still be 1 part blood, but 4 minus 1 gives us 3 parts of saline. So when we are doing that dilution with 30 milliliters of blood, blood's on top, so 30 milliliters goes on top, we are going to cross multiply and divide. 3 times 30 divided by 1 is 90 milliliters. So we use 90 milliliters of saline to dilute that blood. It's very important that we are very accurate with that, because doing a blood reading like this, any errors in that measurement are going to magnify the errors in the true reading. So now that we go to do our true reading, to figure out what our true reading is, we had a 1-in-4 dilution. That was our original dilution. That same ratio of the dilution is going to be the ratio of our true readings. Now we have the meter result of 214, and then we have the true level in the blood. Which one is going to be larger, the meter's result on that diluted sample or the true level in the patient's blood? Well, this is the diluted result. That'll be smaller. The true level in the patient's blood should be larger. So the 214 milligrams per deciliter is going to go with the smaller of these two numbers. So it's going to go with the 1. And we cross multiply and divide. 4 times 214 divided by 1 is 856 milligrams per deciliter. So that is the true reading in this patient's blood. Let's take a slight variation of that problem. In this next problem, we're going to say, again, the patient exceeds the meter. I'm not going to write that out. But here we are going to dilute 200 microliters of urine with 400 microliters of sterile water. The meter result is 382 milligrams per deciliter. I'm not going to add, I told you how much water here, so we don't need to ask that. We need to find the true level in the urine. So find the true level. Well, to find that true level, we would use the dilution along with this diluted reading. But here we don't know the dilution yet. So that's the first thing we have to do is find that dilution. So the dilution, remember, is going to be the amount of serum or concentrate. In this case, that's going to be the urine compared to total volume or total solution. Well, here we know that we have 200 microliters of urine. Our total solution is going to be the 400 plus the 200. The total includes the urine and the water, the saline. So on top, 200 microliters, 400 and 200 make 600 microliters. We have the same unit, so they cancel out. Both of those can be divided by 200, which gives me a 1 in 3 dilution. So now that I know that that was a 1 in 3 dilution, I can go back and figure out the level in the blood. So I use that 1 in 3 dilution. The 382, which we got as a meter reading, is the diluted reading, so that better be the smaller of the two. And we cross, multiply, and divide. 3 times 382 divided by 1 is, what is that, like 1,146 milligrams per deciliter. I'm going to double check that just because it's Friday. It is 1146. So we got that true reading. The other way we could have approached this problem, by the way, is rather than using this right here, rather than adding those two together, we could have done that ratio of urine to saline, which would have been 200 microliters to 400 microliters, and would have given us a ratio of 1 to 2 if we reduced it. And then knowing that that ratio of urine to saline is going to give us a ratio of urine to total of 1. The parts of urine is going to stay the same, but total is going to be 1 plus 2. So a 1 to 3 dilution. So these dilutions do often have several ways that we can approach that final number. Next week, we're going to be looking at using these dilutions to change the concentration of a solution, change the percent. So our concentrate isn't going to be a pure serum, a pure medication, or a pure bodily fluid. The concentrate is going to be just the more concentrated solution, the solution with the higher percent of that active ingredient. And our dilutions work on those as well. There's actually several things we can do on those. One of the things we'll need to recall from back at the last unit, at the very beginning of the last unit, is when we are looking at a solution like that, there are two parts. There is that solvent. The solvent, remember, is the inactive ingredient. So no medicinal value at all. It's just a filler. In most cases, that's water, or in our case, that's that saline, normal, neutral solution. And then there is the dilutant, the material that's going into it, the solute. And that is our active ingredient. In most cases, the serum or bodily fluid or whatever it is we are diluting down. And the amount of that active ingredient, the amount of the solute in that solution, is equal to concentration times the volume. So a solution that is 32% and has a volume of 400 milliliters, the amount of ingredient is going to be 0.32 times that 400 milliliters. Well, 0.32 times 400 is 128 milliliters of that active ingredient, whatever it is. And as we explore these dilutions more next week, this process, this formula, is going to be used to help us dilute these down to a lower level. It's very similar to what we did in the last unit on our mixture problems, only here we are only going to be using a 0% solution to mix with it. So instead of having two solutions of varying percents, we're going to have one solution with a certain percent, and then what we're adding to it is totally neutral. So it's 0% or just sterile water. Some homework dealing with what we discussed today. In the book on page 130 through 132. 1 through 37, the odds. Pay particular attention to the word problems. At the very end, the ones with dealing with blood and urine. Make sure you can find using that meter to find that true reading. Okay, like I said, should have the test. Once I receive all of them, I'll get them graded. I'm done here today actually in another hour and a half, so I probably won't receive them and get them graded today, which means very little chance I'll get them graded right away Monday morning because I have classes straight through before this one on Mondays. So hopefully I'll get them this afternoon or Monday morning, and I'll have them graded before Wednesday's class. But in the meantime, make sure, again, if you have not done corrections on test 1, please redo the problems you got wrong and send me an email with those problems in it so that I can get those points back to you. Okay, with that, you guys have a great weekend.